Honda's advertisement campaign from the early 60s carried the memorable tagline, "You meet the nicest people on Honda." Widely regarded as one of the greatest achievements in marketing history, this campaign portrayed a diverse range of individuals: housewives, parents with children, young couples, and other upstanding members of society, all referred to as the nicest people, enjoying rides on a Honda Cub. The vibrant illustrations and expert design added to its appeal, resonating strongly with the general public. People who might have otherwise dismissed the term motorcycle, or those previously disinterested, began to envision these motorcycles as a fresh option for easy and convenient daily transportation. As Honda ventured into the realm of larger motorcycles, they remained committed to upholding the same brand perception. This commitment was particularly evident when comparing their offerings to competitors like the Kawasaki H2 750. While the H2 earned the moniker Widowmaker due to its wild and untamed nature, the CB754 from Honda embodied an entirely different essence. It possessed remarkable speed, yet Honda pursued this velocity through a distinct approach. It was calm, gentle, and welcoming. However, none of this wouldn't have happened if it weren't for Mr. Yoshiro Harada's journey across the United States on a Honda CB450. Mr. Yoshiro Harada, one of the chief engineers of Honda, embarked on this expedition with the primary goal of enticing more American consumers to embrace the CB450. But the vastness of the US, in contrast to his native Japan, bestowed upon him a fresh perspective. It became evident that, while the CB450 sufficed for Japanese roads, the American terrain demanded something more substantial. This realization spurred the evolution towards larger motorcycles, ultimately shaping Honda's trajectory in the industry. Surprisingly, it wasn't until February 1968 that Harada received approval from Soichiro Honda to embark on a new venture, the creation of a cutting-edge four-cylinder engine, which would become the most pivotal part in the legacy of the CB750. This decision was heavily influenced by Honda's recent investments in computer technology, which Mr. Soichiro believed could greatly bolster Mr. Harada's confidential project. However, by that time, BSA had already initiated the production of their 750cc triples at the small Heath factory. Despite this, Honda nonetheless remained unfazed. They recognized that their recent commitment to computer-assisted design could be harnessed more extensively than ever. This fresh and innovative approach played a pivotal role in expediting the entire development process. With only 20 members, Mr. Harada set out to build the first ever four-cylinder motorcycle from Honda. The project criteria were the following. 1. Keep the entire project cost-effective for mass production. 2. Create comfortable ergonomics for the rider. 3. Develop a four-cylinder engine inspired by Honda's Grand Prix racers. 4. Ensure a steady and dependable cruising speed of up to 100 miles per hour. 5. Design brakes capable of quick and repeated stops from high speeds. 6. Minimize vibrations and noise to prevent rider fatigue during journeys. 7. Enhance the quality of lighting, switchgear, and controls to a higher standard. 8. Prolonged service intervals for greater convenience. Within 6 months, Harada's team had prototyped a four-cylinder ready to go. The creation of this inline-four engine was significantly influenced by Honda's expertise in both racing and production engines. Even the legacy of Honda's Grand Prix Formula car contributed to the development of the CB750. The decision to make it a multi-cylinder was a clear choice aimed at enhancing efficiency. Furthermore, the choice of an inline-four was rooted in Honda's extensive 7-year experience with four-cylinder engines in racing and production cars. However, the inline-four of the CB750 marked a departure from Honda's typical over-square design philosophy. Unlike other Honda motorcycles, the CB750 featured an undersquare bore and stroke ratio of 63 by 67 mm, resulting in a displacement of 736 cc. While this configuration may not seem to offer an immediate efficiency advantage, it becomes apparent that Honda prioritized narrowing the engine width rather than adhering to the trend. The CB750's red line of 8,500 RPM and its power peak, though not exceptionally high, in contrast to the CB350 with a 10,500 RPM redline, demonstrate Honda's decision to deviate from high-revving fashion. This was achieved by opting for a narrower bore, which at 8,500 RPM in a production engine doesn't significantly impact efficiency or piston speed. It's noteworthy that the CB750 engine showcases potential for higher speeds with appropriate adjustments to the valve train. The decision to adopt an over-square design also contributed to improved cooling performance for the CB754, effectively preventing any overheating concerns. This was achieved through generous finning and the strategic separation of each cylinder by spacious air passages, optimizing the cooling process. The cylinder block was ingeniously divided into two halves, with 2 cylinders on the left side and 2 on the right. A gap in the center accommodated the single overhead cam drive. This innovative engine construction, which was quite pioneering in its time, was made feasible for the CB750 through the utilization of shell mold casting. The air-fuel mixture is supplied by 4 distinct Cayenne carburetors, with each one serving a cylinder. These carburetors are equipped with piston valves and double float mechanisms, identical to standard ones, except for an added provision for a vacuum gauge. Adjusting them is straightforward, using separate throttle cables for each, all converging at an engine-mounted junction. This junction is then controlled by a single cable connected to the throttle grip. To fine-tune individual units, the choke levers on each carburetor are linked by an adjustable rod of varying lengths. The rear wheel receives the 67 bhp of power and 60 Nm of torque from the inline-four through a 5-speed transmission. The design of this transmission is quite similar to Honda's previous models, with a minor difference. In other models, the shifting drum also acts as a fork carrier, but in the case of this new CB, its role is mainly to position the forks. These forks pivot on 2 large pins. The clutch system consists of 7 semi-neoprene plates, a departure from Honda's earlier use of troublesome metal plates. Automatic oiling of the final drive chain is facilitated through a special provision in the drive sprocket. This setup allows oil to flow through a drilled pathway in the shaft and be thrown onto the sprocket by centrifugal force. Another notable component is a transfer shaft within the transmission. This shaft, in addition to the countershaft, transfers power to the final drive chain. The CB750 frame showcases robust construction, featuring a complete double cradle along with a main tube, reinforced by 2 smaller auxiliary top rails. These top rails are connected to the main tube through triangulating struts, extending in a straight line from the front down tubes to serve as the top rails for the rear subframe assembly. Notably, the swinging arm assembly is positioned within the cradle, employing 2-piece welded stampings for the arms instead of the conventional tubing. This design choice is attributed to the arm's substantial wall thickness and overall size, ensuring their effectiveness. The suspension provides a comfortable yet distinctly firm ride. The rear spring and damper units, which are nitrogen-sealed shock absorbers by Decarbon, are set to their maximum stiffness for a solo rider weighing 160 pounds or 72 kilograms. To achieve an optimal experience during solo sports riding, it's recommended to maintain the springs at their softer setting. When set to the 2 higher stiffness levels, the reduction in spring travel becomes significant enough to hinder proper damping. This can result in minor rear wheel chatter when aggressively accelerating, braking, or cornering. The front fork springs are robust, limiting excessive movement during heavy braking or fast corners. However, there is a minor issue with immediate rebound on small road bumps, occasionally causing a light up and down motion, especially over regular tar joints or concrete strips. This seems due to the relatively high breakaway friction of the front fork bushings and seals. In Honda's defense, they used the best materials with lower friction coefficients for these components available at that time, so riders had to adapt by adjusting their speed. But this problem naturally improved after several thousand miles, as the bushings and seals wear in. Nonetheless, this slight inconvenience hardly detracts from the bike's reputation as the premier handling machine in its weight class. The CB750 featured an uncommon hydraulically operated single-caliper front brake with a distinctive touch. Notably, the brake disc was crafted from rust-resistant cast stainless steel, setting it apart from the non-stainless options found on other brakes. This choice ensures the disc maintains its showroom floor appearance even after years of use, since it remains exposed to view. However, it's worth noting that these discs had some issues with brake noise due to the poor sound dampening qualities of the stainless steel. To mitigate this potential issue, Honda designed the brake pads with a slightly spherical shape across their gripping surface, allowing for self-centering and helping to address noise concerns. In contrast to various other single and double disc brakes of its era, the Honda braking system exhibits a distinct lack of oversensitivity. This quality becomes especially evident when considering its performance on a machine capable of speeds exceeding 120 miles per hour or 192 kilometers per hour. The brakes performs great. It has minimal fading, maintaining their effectiveness admirably. They possess sufficient stopping capability to even induce front-wheel skidding regardless of the velocity. Although the CB750 proved to be an impressive product from the start, Honda still remained a bit uncertain about its potential success. To mitigate risks, the company chose not to allocate resources to expensive die-cast molds for the engine production. As a result, the initial batch of 7,414 CB750s featured gravity-cast engine cases with a coarse finish. These early models, referred to as sand-cast CB750, have gained legendary status among enthusiasts. Unfortunately, some of the first 7,414 owners encountered issues such as weak castings, broken chains, and other mishaps, leading to the need for case replacements. Owning an original numbers-matching sandcast CB750 is considered the pinnacle among production CB750s. However, the soaring demand for the CB750 prompted Honda to shift its strategy. Recognizing the incredible market interest, the company began to invest more significantly in enhancing the motorcycle's production quality. Consequently, starting from later 1969 models and onwards, Honda adopted more advanced die-casting methods for constructing the engines. This marked a pivotal turning point in the evolution of the CB750, as Honda shifted gears to meet the growing expectations and preferences of motorcycle enthusiasts. The Honda CB750 faced competition from its main rivals, the Triumph Trident and BSA Rocket 3, in the US market. However, the CB750 had distinct advantages that resonated with American customers: a disc brake, electric start, and a 5-speed gearbox with left-side shift, all at a more affordable price. While it's inaccurate to solely attribute the decline of the British motorcycle industry to the CB750, this innovative Honda model did have a significant impact. It not only posed challenges to some companies, but also fundamentally shifted customer expectations within the marketplace. Honda's competitors were compelled to acknowledge that a new standard had been set, leading to an everlasting transformation. The Honda CB750 emerged as a pioneering mass-produced motorcycle. In the world where the twins and triples ruled, it not only made the inline-four engine contemporary, but also made it accessible and reliable. This significant leap in sophisticated engineering helped to coin the term Superbike. This essentially made the Honda CB750 the first superbike in the world. What do you guys think? Leave your thoughts in the comments section below. As always, if you guys enjoyed this video, please give it a thumbs up. Or if you loved it, please consider subscribing to the channel. See you guys next time. Ride safe.